Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having a good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone. Yes, let me know in the chat box with some thumbs ups if I'm audible and visible to everyone. Hello Ashwarya, hi Vansh, hi Teja, hi Lakshmi, hello Bhumi, hi Jashwant, hello Chinmay, hi Bharat. Welcome everyone, welcome back. Just give me some thumbs ups in the chat box so that I'll get to know whether I'm audible and visible to you guys or not. Yes. Let me know fast in the chat box, guys. Hello Shreyas. Hello Dikshita. Perfect, guys. Perfect. Wonderful. Hi Paulomi. Hello Raghu. Hello Surya. Hello Rishita. Yes, Aditya, mock test will be also there, but not today. Okay, day after tomorrow. Okay. Hi Bharat, thank you so much. Thank you. Hello Monisha. Hi Panchami. Hello Vicky. Exactly Teja, this is the most awaited session, yeah? Perfect. So people, as you all must be knowing, today we are starting the new chapter, one of the most important chapters of your chemistry. That's what we call as atomic structure, right? This chapter is all about the concepts, right? And slowly I'll be starting exactly from the scratch, exactly from the basics, and slowly we are going to build the concepts, right? Okay. So just give me some thumbs ups in the chat box if I'm perfectly audible and visible to everyone. Yes. Just give me some thumbs ups. Give me some thumbs ups fast. Yes, Bharat, it is the easy chapter, but at the same time it's the difficult. It's the difficult one at the same time. Just have a look, see from where we'll be starting and see where we are going to take this chapter. Yeah? Perfect. Exactly, I'll be taking the regular sessions for this chapter. Yes, I'll be taking 3 back-to-back sessions for the atomic structure, and then I'll be continuing with the mock test as well. Okay? Perfect, guys. So before starting the session, the ones who are new to the channel, let me introduce myself. My name is Wassim Sir, and I'm your chemistry master teacher writer on this JEE Enthuse channel. Yeah? And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? And do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking on this JEE Enthuse channel, right? So do like the video, share the video with your friends so that all of your friends get benefited out of these sessions, right? And do not forget to subscribe to the channel as well, okay? Perfect. Perfect, guys. So you can let me know in the chat box if you guys are super duper excited about this chapter. You can just give me some thumbs ups in the chat box. Let me see exactly if you guys are super duper excited about the session. Yes. Let me know in the chat box with some thumbs ups, with some fire symbols, so that I get to see the josh of the session first. Then we can start the session directly. Yes, give me some thumbs up in the chat box. No, Chinmay, there won't be a lot of gaps in this chapter, okay? I'll be taking this chapter continuously, okay? Perfect. Yes, Vanchika, this is the starting of the chapter, the first session of the chapter. And I'm sure you guys are ready with your pen and paper. Let me tell you whatever things I'll be writing, I'll be mentioning on the screen. I want you guys to take a note of every single thing which I'll be mentioning on the screen, okay? Perfect. So, in the today's session, we are basically going to cover 2 topics. One is called as Cathode Ray Experiment, and the second one is called as Millikan's Oil Drop Experiment. Both the topics are really very important, okay? Yes, and this is the exact basics of this chapter, right? So without wasting a lot of time, let's get started with something called as discovery of electron, okay? Let's get started with something called as discovery of electron. And people, the experiment which was carried out by J.J. Thomson in 1897 in order to discover the electrons is something which we call as cathode ray experiment, right? Cathode ray experiment. So basically, this is the experiment which we are going to deal in the today's session. And J.J. Thomson was the name of the scientist who did this experiment in 1897, and after carrying out this experiment, electron was discovered. Yes, electron was discovered. So basically, we are going to talk about something called as cathode ray experiment over here in the today's session. Okay, so let's get started with something called as cathode ray experiment. I'm making the heading as cathode ray experiment. Yes, cathode ray experiment, by means of which electron was discovered, right? So first thing, let me make the, just a second guys. Okay, so first of all, I'm going to show you exactly how this electron was discovered by J.J. Thomson. First of all, he took an instrument, basically he took a narrow glass tube, a narrow thin glass tube he took, right? This is the glass tube which he took, right? And let me tell you the first thing, this glass tube was about 60 centimeters long. The narrow thin glass tube which J.J. Thomson took was about 60 centimeters long, right? Well people, in this glass tube what he kept was, he kept a gas. Which gas he kept? He kept hydrogen gas in this glass tube, right? And on the top of the glass tube what he did was, he fixed a vacuum pump at the top of this glass tube, right? He kept a vacuum pump at the top of the glass tube so as to create very, very low pressure inside the tube, right? So basically, at the top of this tube, you will see something called as a vacuum pump, and vacuum pump over here in this tube is used. Why it's used? It's used to maintain the pressure of H2 gas inside this glass tube over here. Yes? Now at the same time, he took two metal strips like this. He took two metal strips, right? And these metal strips were connected with the external battery. These metal strips were connected with the external battery. One metal strip was connected with the negative terminal of the battery, one with the positive one, right? Like this. Let me first of all tell you, that metal rod, that metal strip which was connected with the negative terminal of the battery will have negative charge on it. And that metal strip which was connected with the positive terminal of the battery will absolutely have positive charge on it, right? So people, this metal strip, this electrode is something which we call as cathode, okay? And this electrode which carries the positive charge is something which we call as anode, right? So first of all, let me just give you the quick overview of what I did over here. Basically, I took a narrow glass tube which was 60 centimeters long, and people, let me tell you one more important thing. This tube is what we call as Crookes tube. Basically, the name of the scientist was James Crook, who discovered this tube, and J.J. Thomson used his tube for this experiment, right? We call this tube as the Crookes tube, right? So this tube was about 60 centimeters long. In this glass tube, he kept hydrogen gas, right? He kept a vacuum pump so as to maintain the pressure of the gas inside this container. At the same time, he took two metal strips, two metal rods, I must say, and these two metal rods were connected with the external battery. This is basically a very, very high voltage battery. This is a very, very high voltage battery which he used in this experiment, right? Now, at the same time, what he did was, let me make it for you. What he did was, he coated this side of the tube, with something called as zinc sulfide, right? This side, the inner side of this tube was coated with zinc sulfide, right? Why he did that? There's a property of this zinc sulfide material. For example, I have got a plate like this. Let's say I've got a plate like this. If I coat this plate with the zinc sulfide, yeah, let's say this plate is coated with the zinc sulfide. For example, I have got a particle which has got some mass m, right? Remember, when this particle will strike the zinc sulfide screen, at that point of striking, a bright spot gets created. Yes, a bright spot gets created. There is a property of this zinc sulfide material. When any particle carrying some mass strikes this zinc sulfide surface, okay, at that point where the particle strikes the zinc sulfide, a bright spot gets created. Okay, so basically on this side of the tube, on the inner side of the tube, he coated it with zinc sulfide. Yes? Okay. Now we will understand what he observed. First of all, when he kept the voltage of the battery as 10 raised to power 4 volts, and he kept the pressure of the hydrogen gas as 10 raised power minus 2 bars or 10 raised power minus 2 atm, what he observed was, he observed something strange. He observed some bright spots were being created on this zinc sulfide screen. He observed some bright spots were being created on this zinc sulfide screen. So what could he conclude from there? See, when he kept the voltage of the battery as 10 raised to the power 4 volts, when he kept the pressure of the gas as 10 raised to the power minus 2 bars or 10 raised to the power minus 2 atm, what he observed was, he observed some bright spots getting created on this zinc sulfide screen, which was only possible if some rays are coming from the cathode and striking this zinc sulfide screen, then only bright spots are going to get created. Yes. So what was the conclusion? What was the observation which he made? He observed one strange thing. He saw some bright spots getting created on this zinc sulfide screen, and he said something like this, that there are some invisible rays. There are some invisible rays which seems to be coming from the cathode. And those invisible rays are basically striking this zinc sulfide screen, and where these rays are striking the zinc sulfide screen, their bright spot was getting created. Yes, right? Okay, and let me tell you, the invisible rays, he observed some invisible rays were coming from the cathode, right? Those invisible rays which seems to be coming from the cathode, he called them as cathode rays, right? So again, let me repeat the same thing. So what he observed, when the voltage of the battery was kept very high, when the pressure of the gas inside this narrow tube was kept very low, he saw some bright spots getting created on the zinc sulfide screen, and he concluded some invisible rays seems to be coming from the cathode, and those invisible rays are striking the zinc sulfide screen, and the point where these cathode rays are striking the zinc sulfide screen, at that point bright spots were being created, right? And he called those invisible rays which seems to be coming from the cathode, he called them as the cathode rays. Can you let me know in the chat box if it is clear to everyone? Yes. Can you let me know fast in the chat box if it is clear to everyone? Right? So he called those invisible rays as cathode rays. Okay? Right? Now first thing, he discovered these cathode rays, right? He saw he observed some invisible rays are coming from the cathode. Now it was the time to see the properties of these cathode rays, right? Okay, see, he observed some invisible rays are coming from the cathode, and he called those invisible rays as cathode rays. Now it was the time to see the properties of these cathode rays, right? Okay, now people, for that he did some few investigations. And what were the investigations he did? Understand. The first thing which he did was, see, after discovering the cathode rays, now it was the time to see whether these cathode rays travel in straight lines or not. Yes, after discovering these cathode rays, it was the time to check whether these cathode rays travel in straight line or not. So what he did for that? He simply did one simple thing. He kept an object in between. This is the object, for example. And behind this object, he kept a zinc sulfide screen again. Behind this object, he kept a zinc sulfide screen again. And what he observed when he again turned the battery on, he saw a sharp image of the object was being created on this screen over here. A sharp image of this object. This is the object. When he turned the battery on, he observed a sharp image of this object is being created on this zinc sulfide screen, which is only possible when these cathode rays travel in straight lines, right? Okay, which is only possible. Only the sharp shadow, the sharp image will only get created on this screen, right? When these cathode rays will be traveling in the straight line. So first thing. What is that? The cathode rays travel in straight lines. This was the first conclusion made by J.J. Thomson. The cathode rays travel in straight lines. Okay. So first thing which he noticed, Now the second thing. Since he checked these cathode rays are actually traveling in straight line. That's why a sharp image of the object is getting created, right? Now the point was, what are these cathode rays made up of? Are these cathode rays made up of particles, right? If these cathode rays are made up of particles, do those particles have some mass, right? It was time to check that now. So for that purpose, what he did was, he kept a light paddle wheel over here. Okay, he kept a light paddle wheel over here, which was made up of mica, right? When he again turned the battery on, he saw the paddle wheel was rotating. He observed the paddle wheel started to rotate. When the battery was turned on, the paddle wheel started to rotate. What can you conclude from here? What can you conclude? See, he's turning the battery on and he's observing something strange, that this paddle wheel is rotating. Yes. What can you guys conclude from that? People, it's a very simple thing. See, this is the paddle wheel, right? This is the paddle wheel, for example. This is the paddle wheel. This paddle wheel will only rotate, when some particles carrying some mass will be striking this paddle wheel. Okay, so these particles, if these particles carry some mass, okay, these particles, when they'll strike this paddle wheel, then only the paddle wheel will start to rotate, I must say. Okay, yes, right? So what he noticed, again I'm telling you the same thing, when he turned the battery on, he saw the paddle wheel was rotating, which is only possible if some particles having some mass are striking it, and those particles after striking are making this paddle wheel to rotate. Yes. So people, he observed one more thing. He concluded one more thing. What was that? He observed the cathode rays, the invisible rays, which he called as cathode rays, are made up of some particles. Are made of some material particles having certain mass. Right? He observed this also. So basically, the cathode rays are made up of some material particles which have got some mass, and those material particles are basically striking this paddle wheel and making this wheel to rotate. Okay? Right? Now, first, he observed some invisible rays are coming, which he called as cathode rays. Second, he observed these cathode rays are traveling in straight lines. Third thing he observed, the cathode rays are made up of some material particles which have got certain mass. Right? Now it was the time to check whether these particles of which the cathode rays are made up of, are these charged or not. What he did for that? Let me tell you first thing. For example, this is one U-type magnet which I have. Let's say this is one U-type magnet which I have, correct? Right? Every magnet has got some magnetic field associated with it. You must have studied this in your class 10th as well, right? Every magnet has got some magnetic field associated with it, right? Remember, when a charged particle passes through this magnetic field, it gets deflected, right? Its direction changes. The charged particle was supposed to travel in the straight line, but in presence of this magnetic field, it started deflecting, right? Okay, what he did over here was, in order to check whether these particles of which cathode rays are made up of, are they charged or not, what he did simply was, he kept a U-type tube over here. He kept a U-type magnet over here, right? As I told you, this magnet will be having some magnetic field associated with it, right? And what he observed? He observed these cathode rays in presence of magnetic field were being deflected towards the magnet. Which is only possible if the particles of which cathode rays are made up of are actually charged, right? Okay, so from here, what he observed, can you let me know in the chat box what he observed? He observed the cathode rays of which the cathode rays which are made up of material particles, those material particles are carrying certain charge, right? So the third conclusion which he made, that the material particles, I'm sure you're writing everything with me, right? He observed the material particles of which these cathode rays are made up of of which these cathode rays are made up of carry certain charge. Carry certain charge, right? This was one more conclusion made by J.J. Thomson. Yes, right? Now people, see from where we started. First of all, he observed some bright spots getting created on zinc sulfide screen. And he concluded that some invisible rays are coming from cathode. Second, talking about the properties of those invisible rays. Those invisible rays, they are traveling in straight lines. Point number 2, those invisible rays are made up of certain material particles which carry certain mass. Conclusion number 3, those material particles, they carry some charge as well. That's why those material particles got deviated. They got deviated, right, in presence of the magnetic field. Now, it was the time to check whether the charge carried by the material particles of the cathode rays, whether it is positive or negative. What he did for that? Now, it was the time to check whether the charge carried by the material particles of the cathode rays, whether it's positive or negative. So, for that purpose, what he did was, understand. What he did was, have a look. He kept 2 plates over here, one plate carrying a positive charge, one plate carrying a negative charge, right? We know unlike charges attract each other. Yes, we know unlike charges attract each other. Yeah. Now people, what he observed was, when he turned again the battery on, he observed these cathode rays, they were being deflected towards the positively charged plate over here. They were being deflected towards the positively charged plate, which is only possible. The material particle of which the cathode rays are made up of, those material particles must be negatively charged, then only those material particles will be getting deflected towards the positively charged plate, right? Okay? Yes. People, it's a very simple thing. See, he kept 2 plates over here, one carrying positive charge, one carrying negative charge, right? And when he turned the battery again on, he saw something strange. What was that? He saw the cathode rays were being deflected towards the positively charged plate, which is only possible if the cathode rays of which, the material particles of which the cathode rays are made up of, those must carry negative charge, then only these cathode rays will be getting deflected towards the positively charged plate, right? Okay, so one more conclusion he gave. He gave the conclusion, the charge carried by the material particles is negative. So people, finally what he concluded? He concluded something as, there are some invisible rays coming from the cathode, right? Okay, those invisible rays are traveling in a straight line. Point number 1. Point number 2, those invisible rays are made up of some material particles which carry certain mass, right? Those material particles, they have got some charge present on it. The charge present on the material particle is negative. He called those material particles of which cathode rays are made up of, he called those material particles as negatrons, right? He called those material particles as negatrons. Let me write it over here again so that it will be clear to you. He called the material particles of which cathode rays are made up of, carrying some negative charge, as negatrons. So basically, in the beginning, when these cathode rays were discovered, it was seen the cathode rays are made up of some material particles which carry some negative charge, and those negatively charged particles of which cathode rays are made up of, he called those negatively charged particles as negatrons. And later on, the name was shifted from negatrons to electrons. right? So negatrons was then replaced by electrons, and Stoney was the name of the scientist who did it, right? Stoney was the name of the scientist who changed it from negatrons to electrons, right? Can you let me know in the chat box if everything is clear till here? Farhan, I'll be letting you know about that. Can you let me know in the chat box if everything is clear till here? Absolutely, exactly, guys. This is for JEE, right. Can you let me know in the chat box if everything is clear till here? Yeah. So I'm sure you got to know about the cathode rays, right? Okay. And you got to know some properties of these cathode rays as well. Okay. Manaswini is saying why name was changed from negatrons to electrons. Ye raaz bhi unhi ke saath chala gaya. Okay. So people, now few more properties about these cathode rays, yeah? Few more properties about these cathode rays. The cathode rays produce heating effect. They produce heating effect when strikes with some specific metals, right? Okay. Now people, one more thing was observed. What Thomson did was he kept a metal in between, and he again turned the battery on, and he saw after some time the metal got hotter, its temperature increased, right? So he concluded something that the cathode rays which are striking this metal, they are producing the heating effect, okay? Right? So the cathode rays, they produce the heating effect when strike with certain specific metals, okay? And at the same time, he observed one more thing. These cathode rays, when they strike a heavy element, some X-rays were produced. X-rays were produced. I want you guys to take a note of this statement as well. See, when cathode rays were striking some heavy metals, okay, after striking with some heavy metals, X-rays were being generated over here, right? X-rays were being produced. This is one more thing which you need to remember, right? When the cathode rays, when they strike some heavy element, what is going to happen? X-rays will be getting produced. This was one more conclusion made by J.J. Thomson. Yes? Can you let me know in the chat box if it is clear to everyone? Yes? Let me know fast so that we can talk about something really interesting. This was just the history, how the cathode rays were introduced. Yes? Hello Shiva, welcome. Perfect guys, perfect. Now comes something important. By carrying out this experiment, one important thing was done. Basically, by carrying out this experiment, specific charge of the electron was calculated. Specific charge of the electron was calculated. Specific charge means the charge present on the electron divided by mass of the electron, right? Specific charge of electron was calculated by carrying out this experiment. Now the point is how this term, how charge by mass ratio, how E by M ratio, this is something which we call as E by M ratio, right? How E by M ratio of electron was calculated, right? How E by M ratio, how charge by mass ratio of the electron was calculated. Now it is the point, okay? For that purpose, what he did, understand properly what I'm going to say. See guys, this is a positive plate over here. This is a positively charged plate over here, right? And at the same time, I'm placing a U-type magnet over here as well. Okay, right? So first thing, let's assume this is the cathode ray which is coming from here, right? Okay, so this cathode ray right now, it'll be experiencing two forces. One force due to the magnetic field. This magnetic field wants this cathode ray to get deviated towards itself. But at the same time, this positively charged plate, it wants the cathode ray to get deviated towards itself, right? So basically, the material particle of which cathode ray is made up of, it is experiencing two forces. One is the magnetic force, which I'm representing by Fm, and one is the electric force. So this particle is experiencing two forces right now. What all forces? One force due to the magnetic field, another force due to the electric field, right? Magnetic field wants this particle to get deviated towards itself, and this electric field, it wants this particle to get deviated towards itself, right? Now people, if I try to balance these two forces, can I say the particle will travel in the straight line? Okay. If I try to balance these two forces, magnetic force as well as electric force, can I say at that time, after balancing these two forces, can I say the particle will travel in a straight line? Okay. So basically, this is the particle. In this direction, the particle is experiencing electric force. In this direction, the particle is experiencing some magnetic force. Okay. If Fe is greater than, I'm giving you the condition. If Fe is greater than Fm, I'll say the particle will slightly get deviated towards this direction. If Fm is greater than Fe, I'll say the particle will get deviated in this direction. If Fm is equal to Fe, I'll say the particle won't get deviated. It will pass in the straight line. Yes? Okay. So people, after balancing these two forces, the particle passed in a straight line. Okay. It moved undeviated. Now people, what happened over here? Understand. What is Fm? This is the force experienced by the electron. This is the force experienced by the material particle due to magnetic field. What is Fe? Fe is the force experienced by the same electron due to the electric field. Well, let me tell you, the force experienced by the electron due to the magnetic field, that's always equal to Q multiplied by V multiplied by B. This is something which you'll study in your class 12 physics. Q is the charge present on electron. V is the velocity with which the electron moves. B is the magnetic field strength which got created due to this magnet. Okay. Similarly, this electric field, this is something which you'll study in your class 12 too. The force experienced by the electron by the charged particle, right, due to electric field, that's equal to Q multiplied by E, where Q is the charge present on electron and E is the electric field strength, right? So can I say Q and Q got cancelled? So from here, he calculated the velocity with which this electron was moving, which was E divided by B, right? E is basically the electric field strength and B is the magnetic field strength. And what he observed, knowing the values of E as well as B, he already knew the value of E, he already knew the value of B. Knowing the values of E and B, he observed the velocity with which the cathode rays travel with the velocity which is going to be 1/10 of the velocity of light. Okay. So these cathode rays, these are basically traveling with the velocity which is basically 1/10 of the velocity of light. Okay. So from here, he got the velocity of the electron, which is basically velocity of the cathode ray, which is basically electric field strength divided by magnetic field strength, right? Now people, how he calculated the charge by mass ratio? E by m ratio, specific charge of the electron. That is the point now. Okay. Let's try to understand how he calculated that mathematically. Okay. For that, let me erase this part. Okay. Understand what I'm going to tell you now. Let's say this is one plate, this is one more plate, right? This is the external battery which I'm connecting. Okay. Just keep the scenario like this. See, this is the plate, this is one more plate, like this, okay? And both these plates are basically connected with the external battery over here. This plate will be carrying a positive charge, this plate will be carrying a negative charge because this plate is connected with the positive terminal, this plate is connected with the negative terminal, right? Now people, for example, if I put an electron over here, right? If I put an electron over here, what's going to happen? Can I say the electron has got strong tendency to move towards this positively charged plate because this positively charged plate is going to attract this electron towards itself, right? At the same time, this negatively charged plate, it is going to repel this electron, right? So basically, I'm still holding the electron, but this electron is experiencing a force in this direction, right? So this electron right now, it has got some electrostatic potential energy due to which it wants to go in this direction. Yes? So this electron has got some electrostatic potential energy over here. And the electrostatic potential energy, which I'm denoting by U, right? Electrostatic potential energy which the electron has right now, it's equal to charge present on the electron multiplied by voltage of the battery, or you can say potential difference between these two plates, which I'm representing by V, right? Or you can say this you can call as voltage of the battery as well, right? Okay, understand properly. The electrostatic potential energy which this electron has right now, it is basically equal to the charge present on this electron multiplied the potential difference between these two plates multiplied by the voltage of this battery, right? Now people, Now people, I'm leaving this electron now. I'm leaving this electron. Can I say this electron will start to move in this direction? Absolutely, right? Can I say the potential energy which this electron had, it is getting converted into the kinetic energy? Absolutely. The potential energy which this electron had, it is getting converted into what? Kinetic energy of the electron, which is half of mv square, right? So the electrostatic potential energy which this electron had, when I leave this electron, the electrostatic potential energy of the electron is getting converted into its kinetic energy, due to which the electron is moving towards the positively charged plate. Yes? Okay? Right? Now people understand. Now people understand. Be careful with certain things. What is Q? Q is the charge present on the electron. What is V? V is not the velocity of the electron over here. V is the voltage of the battery. Let me represent it by capital V. V is the voltage of the battery. What is this M? M is the mass of the electron. V is the velocity with which the electron moves. Correct? Right? Okay. So people, from here, can I get the value of V square? I mean, this V square I'm eliminating. This V square is simply going to be equal to Q multiplied by capital V divided by what? Divided by M. Correct? What is this V? V is the velocity with which the electron is moving, right? In the discharge tube, basically. Yes. And people, we knew this value of V. This V value we have already calculated. It is basically equal to E divided by B. Electric field strength divided by magnetic field strength, right? Okay, so people, instead of this V square, I'll be writing E square by B square. So I'm writing basically E square divided by B square is equal to 2 times Q multiplied by V divided by M, right? Let me write it somewhere here. The final result which I got something as E square divided by B square is equal to 2 times Q multiplied by V, where V is the voltage of the battery, divided by what? Divided by M, correct? So what am I basically supposed to calculate? I'm supposed to calculate the charge by mass ratio of electron, right? I'm supposed to calculate Q divided by M of electron. I think we got it. This is Q, this is M. Can I say Q divided by M of electron? It will be simply equal to E square divided by 2 times, this is B square as such, Q divided by M is equal to E square divided by 2 times B square multiplied by V, right? Now people, this E is something which I call as electric field strength, which he already knew. B is the magnetic field strength, which he already knew, right? V is the voltage of the battery, which he already knew. So knowing all these values, putting the values of all these terms into this equation, he got the Q by M ratio of the electron, which was found out to be 1.676 into 10 raised power 11 coulomb per kilograms. So this is how he calculated the charge by mass ratio of the electron, right? This is how he calculated the charge by mass ratio of the electron. Can you let me know fast in the chat box if it's clear to you? Yes? Yes? Let me know fast. Let me know fast if it's clear to everyone. Yes? Perfect? Perfect. Yes, Manglam, I'll be finishing state for matter 2. Give me some green signal from the chat box if you got it clearly. So by means of this mathematical thing, he calculated the charge by mass ratio of the electron, which was found out to be 1.76 into 10 raised to the power 11 coulomb per kilograms. Yes? Right? Perfecto. Hariharan, I get your concern. Basically, I'm teaching on 3 channels. That's why my video on this channel is only 1 for a day. Okay? I take care of 3 channels basically. NEET Elite, this channel, and sometimes Catalysis, right? And there are a lot of new surprises coming up. Okay? Which I'll be telling you in some time. Perfect. I'm sure it's clear to everyone, right? So people, this is how charge by mass ratio of electron was calculated, right? Okay, let me summarize it. The cathode ray experiment, this is the setup which was created, which I already showed you. Okay, they produce a sharp shadow of the object placed in their paths. This shows that cathode rays travel in straight lines, right? If a light paddle wheel is placed in the path, the wheel starts to rotate. This is something which we have done. When the cathode rays are passed through an electric field, they are deflected towards the positive plate. This shows that the rays carry some negative charge, right? And people, similarly, these negatively charged particles of which these cathode rays are made up of. These are called as negatrons, and later on the name was changed from negatrons to electrons, right? This is something which we did. When cathode rays strike a metal foil, it becomes hot. This indicates rays produce the heating effect. This is something which we have done, right? And at the same time, they produce X-rays when they strike against the surface of the hard metal like tungsten, okay? So basically, when these cathode rays, when they strike the hard metal, heavy metal like tungsten, X-rays will be getting produced, okay? And this is how he calculated the charge by mass ratio, which I told you now, okay? Right? And people, which gas he used for this experiment? Initially, he used the hydrogen gas. When he used the hydrogen gas, he calculated E by M ratio. E by M ratio was found out to be 1.76 into 10 raised power 11 coulomb per kg. Then he replaced the gas. Instead of hydrogen, for example, he used oxygen. For oxygen also, E by M ratio was coming out to be the same, right? Then he changed the gas again. For the another gas, E by M ratio was again coming out to be same for the cathode rays, right? And then what he observed? He observed E by M ratio of cathode rays, E by M ratio of electron is independent of the nature of the gas taken. It is independent of the nature of the gas taken. And at the same time, okay, it's independent of what? It's independent of the nature of gas taken. So remember, E by M ratio of cathode rays, it is actually independent of the nature of gas taken. I'm sure it's clear to everyone, right? This is how E by M ratio of electron was calculated. Now, there is something important. That's something which we call as Millikan's oil drop experiment. So there was one scientist called as Millikan. He carried out one beautiful experiment, and by having a look on that beautiful experiment, which I'm showing you in some time, he calculated actually the charge present on electron. What Thomson did, he calculated E by M ratio of electron. He did not calculate the charge present on electron. Charge on the electron was calculated by one more scientist called as Millikan by his experiment, which we call as Millikan's oil drop experiment, right? I'll be exactly showing you by the mathematical calculations how he calculated the charge present on electron. First, you let me know in the chat box if everything is clear till here, right? Yes? Perfect, guys. So let me show you exactly how Millikan, through his experiment, calculated the charge present on electron, right? Before that, let me give you one concept. There is something called as Stokes Law in physics, which you will study in your class 11 physics. Let me give you just idea of that, because I'm going to use that concept of your physics in this experiment. I'm not sure whether you have studied the Stokes Law yet. If not, then have a look. I'll just give you the quick summary of Stokes Law, because I'm going to use that over here in this experiment, right? Have a look. Understand. This is, for example, the Earth's surface. This is the Earth's surface, right? Okay. I have got a particle over here. This is the particle which has got certain mass, m. Okay. The initial velocity of this particle right here is 0. That means I'm holding this particle right now. I'm not letting this particle to fall on the Earth's surface, right? This is the Earth's surface, correct? Now basically, over here there is some air, correct? Now people, when I'll drop this particle from certain height, it will start falling down. Right? The particle started falling down. The particle reached somewhere here. Okay. Can you let me know how many forces will be experienced by this particle right now? One force will be due to gravity, right? In this way, which is going to be mg. There'll be one more force whose direction will be opposite to the direction of motion. There'll be one more force whose direction will be opposite to the direction of motion of the particle. That's something which I call as viscous force. Right? What is viscous force? What is viscous force? Viscous force is due to the air in the atmosphere, right? And the direction of viscous force will be in this way, which I'm representing by Fv. Okay? Viscous force is basically the frictional force due to air. Right? Or you can call that as air resistance as well. Right? So people, this particle is right now experiencing two forces. One is mg, one is viscous force in the upward direction. Okay? Now when the particle was here, when the particle was at rest, there was no viscous force on the particle. Now the particle started coming down. The particle started gaining some velocity. The viscous drag started to increase in the opposite direction. There will be a time when both these forces will be equal. There will be a time when both these forces will be equal, right? when both these forces will be equal, I'm writing Fv is equal to F due to weight, due to gravity, or let me write it as Fg. Okay, there'll be a time when these two forces will be equal. At that time, the net force present on this particle will be 0. And once the net force present on the particle will be 0, after that point, the particle will start moving with the constant velocity. And that constant velocity which is attained by this particle when net force on it became 0, that velocity is something which I call as terminal velocity. That velocity is something which I call as terminal velocity. Okay, so what is the terminal velocity of this particle? What is it basically? Terminal velocity is the speed which is acquired. This is basically a uniform speed. This is basically a uniform speed, uniform velocity acquired by this particle when the net force on it became 0. Right? Okay, absolutely. Absolutely, guys. Now have a look. What is Fv? This is the viscous force. Remember, as per Stokes law, viscous force is always equal to 6 pi neta r v is equal to Fg, force due to gravity, that's going to be mg, right? Okay, let me give you the terminologies. What is this n over here? N over here is something called as coefficient of viscosity. This is something which you will be studying in your physics. Coefficient of viscosity, right? Okay, what is this r? Leave the r aside, or let me tell you, this r is the radius of the particle, right? R is the radius of the particle. V is the constant velocity which this particle acquired when net force on it became 0. So V is something which I call as terminal velocity. V is something which I call as terminal velocity. What is m? M is the mass of the particle. What is g? G is the acceleration due to gravity which is being experienced by this particle, right? Okay, how and where I'm going to use this statement? How and where I'm going to use this law? Understand? That's something which I'll be using in the Millikan's oil drop experiment, right? So let's get started with something called as Millikan oil drop experiment, by means of which he calculated the actual charge present on an electron, right? So people, what I'm doing over here is I'm taking a cubical apparatus over here. Okay, I'm making a cube first of all. Understand what I'm going to do. Properly understand. This is the cube which I made, right? Now this cube I'm going to divide into two parts. This cube I'm dividing into two parts like this. Okay, this cube I divided into two parts. One part, one more part, right? Now this is the plate in the between. This is plate in the middle, okay, which divided this cube into two parts. I'm going to create a hole at the middle of this plate. I created a hole at the middle of this plate. And people, on one side of it, I'm attaching something called as atomizer. What this atomizer does, it sprays the oil droplet in the upper half of this cube. It sprays the oil droplets in the upper half of the cube, right? And in the bottom half, in the below half, I'm keeping hydrogen gas. Right? What I'm doing first of all is, I'm making X-rays to fall on hydrogen gas. What happens first of all? Remember, when X-rays, when they fall on hydrogen, there are first of all hydrogen gas molecules. These are hydrogen gas molecules. Remember, when these X-rays will fall on hydrogen gas molecules will start to ionize. They'll start to lose electrons. Right? They'll start to lose electrons like this. Okay, hydrogen molecule. Since one hydrogen atom will lose one electron, so two hydrogen atom of which molecule is made up of which this hydrogen molecule is made up of, it's going to lose two electrons over here. Yes? Right? Now people, in the bottom half over here, we have got some ions, H positive ions, and with these H positive ions, I have got some electrons as well, right? These are the electrons which have come out from the hydrogen gas molecules when X-rays fell on these H2 molecules, right? Okay, so in the top half, what do I have? I have got oil droplets. In the bottom half, what do I have? I have got H positive ions, and with these H positive ions, I have got some electrons as well. Okay, now people understand properly what I'm going to say. See, these are the oil droplets inside this cube, inside the upper half of the cube, right? Can I say one of the oil droplet can come through this hole in the bottom half? Yes. Let's say one of the oil droplet is coming from this hole, right? And finally reached here somewhere. This is the oil droplet over here. Let me tell you, there is a property of the oil droplet. Oil droplets, they capture the electrons. If I'll bring some electrons in the vicinity of the oil droplet will be capturing the electrons towards it. Okay, so can I say these electrons are basically in the vicinity of this oil droplet, and these electrons will be getting captured by this oil droplet, due to which there will be negative charge on this oil droplet. Okay, absolutely right. So this oil droplet, it contains what? It contains the negative charge because it has captured the electrons which are in the vicinity of it. Yes? Okay. Now people understand properly. When this oil droplet will start to come downwards, see, I'm making the oil droplet somewhere here, right? This is the oil droplet. The oil droplet which came through this hole. Now this oil droplet, can you let me know how many forces are being experienced by this oil droplet? One force will be due to its weight, that's mg. That's mg, right? And when this particle will be falling down, when this oil droplet will be falling down, there will be a viscous drag in the upward direction, Fv. The direction of viscous force is always opposite to the direction of motion of the particle. See, this oil droplet, it's falling downwards. And this oil droplet, it's experiencing one more force, that is the viscous drag, right? Okay. Can I say when the particle will start falling down, it will gain some speed in the beginning. And there will be a time when net force on the particle will be 0, when Fv becomes equal to mg. There will be a time when viscous force becomes equal to the force due to gravity, right? At that time, what will be the F net of the molecule? Net force on this oil droplet will be 0. And when the net force on oil droplet becomes 0, particle gains a constant velocity, which I call as the terminal velocity, right? So now, when the F net on the oil droplet becomes 0, I'll say the particle will start to fall with a uniform velocity. That's something which I call as terminal velocity, and right now I'm representing that terminal velocity by V1. Yes? Okay? Understand, people, properly understand. So first of all, these two forces got balanced. So I can say Fv, which is the viscous force, 6 pi neta r V1, where V1 is what I call as terminal velocity, right? Is equal to Fg. Fg is force due to gravity, that's mg, right? Okay. What is m basically? M is the mass of the oil droplet. If I'll ask you, what is going to be density of oil droplet? Can I say density of oil droplet will be equal to mass of oil droplet divided by volume of oil droplet? What is the volume of oil droplet? Since oil droplet is spherical in shape, so it's going to be 4 by 3 pi r cube. So from here, can I calculate the mass of oil droplet? Absolutely. It's going to be density of oil droplet multiplied by 4 by 3 pi r cube. Absolutely, right? So people, in this equation, instead of m, I'll be writing this whole thing, right? So I'll be getting something like this, 6 pi neta r V1, where V1 is the terminal velocity which the particle attained, is equal to m. M is simply going to be density of oil droplet multiplied by 4 by 3 pi r cube multiplied by g, right? Can I say one of the r and one of the r got cancelled, right? So what did I get? I got something like this, 6 pi neta V1, divided by, this is the density of oil droplet, right? Multiplied by 4 by 3 is coming downwards, right? There is pi as well, there is g as well, is equal to r square, something like this, yes? So first of all, this pi got cancelled, so this 3 will go up, so 6 3s are 18, 18 divided by 4 will be 9 by 2. So you got something as 9 divided by 2, pi got cancelled, 9 by 2 neta V1, 9 by 2 neta V1 divided by density of oil multiplied by g, its root is equal to r. So this is how I calculated, first of all, the radius of the oil droplet, yeah? I calculate the radius of the oil droplet. This is the radius of the oil droplet. Yes? Okay. What is V1? V is the terminal velocity which this oil droplet occurred, right? Okay. Now people, this is something which you would have copied. I want you guys to remember this relation, because from this relation, question can be asked. You'll be supposed to simply calculate the radius of the oil droplet. If you remember this relation, you can easily kill it. Okay. Now understand what I'm going to do next. Right? This is something which I'm writing as such, okay? I need some space so that I'll show you a few more interesting things. Now people understand one more thing. See, now what I'm going to do is, this is the plate, this is one plate, this is one more plate over here. I'm going to join these plates with the external battery. Right? I'm going to join these plates with the external battery. That plate which is connected with the positive terminal will carry positive charge on it. So the upper plate, the top plate, will be having some positive charge on it. Let me change the color so that it will be properly visible to you. This is the positive charge on the upper plate, right? And on the bottom plate, there will be some negative charge because the bottom plate is attached with the negatively charged terminal of the battery. Yes? Now people understand. The oil droplet will start coming downwards, and when the oil droplet will reach in the bottom region, it will capture the electrons, right? So there'll be negative charge on this oil droplet. There'll be negative charge on this oil droplet, okay? So now if I'll ask you, how many forces will be getting exerted on this oil droplet? How many forces will be experienced by this oil droplet? One force, since the oil droplet right now is falling downwards, I'm assuming, one force will be mg. One force will be mg, right? Right? The another force will be now the electrical force, because see, this oil droplet carries a negative charge. This plate carries a positive charge. This positively charged plate will start to attract the oil droplet towards itself, due to which this oil droplet will experience one force, that is electrical force in the upward direction, right? Okay. At the same time, understand, if I increase the voltage of the battery, the positive charge on this plate will try to increase. If the positive charge on this plate will try to increase, I'll say this Fe will start to increase. Right? Okay. And when Fe starts to increase, there will be a scenario when this oil droplet will start to go up. If I'll keep on increasing the Fe, if I keep on increasing the potential of the battery, if I keep on increasing the voltage of the battery, the positive charge on this plate will keep on increasing. And if the positive charge on the top plate keeps on increasing, I'll say Fe value will keep on increasing. And there will be a time when Fe will be greater than mg. At that time, the oil droplet will start going upwards, right? And people, when the oil droplet will start going upwards, how many forces will be experienced by this oil droplet? Let me write it somewhere here. When the oil droplet, in presence of electric field, when it will start going upwards, how many forces will be experienced by this oil droplet? One force will be mg in this way, right? Another force will be electrical force in the upward direction. And I'm assuming the particle is moving upwards. If the particle is moving upwards, there will be viscous force opposite to the direction of movement of this oil droplet, okay, in the downward direction. See, the particle is going upwards. There are three forces which are being experienced by this oil droplet. Can I say there will be a scenario on adjusting the voltage continuously? There will be a scenario when the upward force will become equal to the downward force. Absolutely, when the upward force will become equal to the downward force. When Fe becomes equal to mg plus Fe. Okay, right? And people, when the upward force and downward force becomes equal, I'll say at that time, net force on the molecule will be zero. Net force on the oil droplet will be zero. And when the net force on the oil droplet will be zero, the constant velocity with which the oil droplet will be going upwards, that's something which I call as terminal velocity, which I'm now representing by V2. So what is V2? V2 is the terminal velocity in presence of electric field. Right? What was V1? V1 was the electric field, V1 was the terminal velocity in absence of electric field. Right? V2 was the terminal velocity in presence of electric field. This is the terminal velocity in absence of electric field, right? Okay. But today there won't be any mock test, okay? Mock test will be day after tomorrow. Now people, see, what is Fe basically? Fe, simple, it's going to be Q multiplied by E, right? Fe is basically the electrical force, which is basically charged on the oil droplet multiplied by electric field strength is equal. Instead of this mg, can I write 6 pi neta R V1? 6 pi neta R V1 plus, what is Fe? Fe is the viscous force now. It's going to be 6 pi neta R V2 in presence of electric field, yes? So from here, can I write something like this? QE is basically equal, I'll take 6 pi neta R common. It's going to be V1 plus V2, right? So from here, I can calculate the value of Q. Q is going to be 6 pi neta R, I have taken common. It's going to be V1 plus V2 divided by what? Divided by E, right? People, look at this expression. What is Q? Q is the charge present on oil droplet. 6 is constant, pi is also constant. Neta value, it's already constant. It has got a fixed value. We know this theta value. R, radius of the oil droplet, which we already know from here. R we know. V1 is the terminal velocity in absence of electric field. V2 is the terminal velocity in presence of electric field. And E is the electric field generated due to this battery. Okay, right? Yes? Right? So people, all the things which are needed to calculate Q, we already have all the values of these things, right? So from here, can we calculate Q? What is Q basically? Q is the charge present on oil droplet. And remember what Millikan observed? He observed the minimum charge which the oil droplet possessed. The minimum charge which the oil droplet possessed. That was minus 1.6 into 10 raised power minus 19 coulombs. The minimum charge which the oil droplet possessed, that used to come as 1.6 into 10 raised power minus 19 coulombs. Right? Or as per Millikan, the minimum charge, if the particle carrying some charge, if the particle has got some charge, the minimum charge that a particle carries, that's going to be this much. Or the charge can be 2 times this, or the charge can be 3 times this, or the charge can be 4 times this. So basically, whenever I'll be having a particle which carries certain charge, the charge present on the particle is going to be the integral multiple of this value. Integral multiple of this value. Right? So what you observed? Q is equal to N multiplied by E, where E value is basically 1.6 into 10 raised power minus 19 coulombs. Right? What he observed? He calculated the value of Q, right? Q was the charge present on oil droplet. And he observed the minimum charge present on oil droplet can be 1.6 into 10 raised power minus 19 coulombs. Right? Okay? Or it can be 2 times this, or it can be 3 times this, or in general, he said the minimum, the charge present on the charged particle can always be in the integral multiple of this A, right? Okay? Right? Yes, Shiva, I'll be doing that. So people, this was some mathematical calculation which he did, and by means of this, he calculated the value of Q. Q was the charge present on the oil droplet, and he observed the minimum charge present on oil droplet will be minus 1.6 into 10 raised power minus 19 coulomb, right? Okay? And he concluded an important statement. He concluded one important statement. And what was that statement all about? Let me show it to you. Let me show it to you exactly. Let me show it to you exactly. From this experiment, he calculated the minimum charge present on the oil droplet, which was 1.6 into 10 raised power minus 19 coulombs, right? Okay. And any particle, if charged, will have the charge which will be integral multiple of this value. Okay. So if I'll be having any particle which carries some charge, the charge minimum can be 1.6 into 10 raised power minus 19, or it can be 2 times, 3 times, or in general I can say the charge on the charged particle can be the integral multiple of this value, right? Okay, I'm sure it's clear to everyone, right? So people, this is how the charge on electron was calculated, right? By Millikan's oil drop experiment. Now the point is how the mass of electron was calculated. Since Thomson already calculated the specific charge of electron, which is basically represented by E by M, okay, and it was calculated as 1.76 into 10 raised power 11 coulomb per kg, right? Specific charge of electron was already calculated. Now what Millikan did, Millikan calculated the charge present on electron, which was how much? Which was 1.6 into 10 raised power minus 19, right? Divided by M is equal to 1.76 into 10 raised power 11, right? So from here, he calculated the M value, mass of electron, which was found out to be how much? 9.11 into 10 raised to the power minus 31 kilograms. This is how he calculated the mass of electron as well. Okay? This is how he calculated the mass of electron as well. Yeah? Right? Yes, Mahi, if you will change the gas, E by M ratio of cathode rays is going to be same. Yes? E by M ratio of the cathode rays, that's independent of basically the nature of the gas taken, right? I'm sure it's clear to everyone, right? So this is how we calculate the mass of electron. So people, I'm giving you one question as the homework, right? This is the question which you guys are going to do. This is going to be your homework on the Millikan's oil drop experiment. It's a very simple question. I have already given you the formulas, right? To calculate the radius, right? To calculate the charge. Okay, you know the formulas, you know how to calculate R, you know how to calculate Q, all the parameters are given in the question. You are going to let me know the answer of this question in the comment section, right? Okay. Perfect. Right, so people, this was all from my side in the today's session, right? So people, tomorrow there'll be one more session on the same atomic structure. Tomorrow we'll see the discovery of anode rays, we'll see how neutron was discovered, and most probably tomorrow only we'll see the Rutherford's experiment and Thomson's model as well, right? Okay. Triambar, because I'm not getting time, I'm handling 3 channels, you know it, right? Okay, so people, if you have not joined into the long-term platform, long-term course on Vedantu, please do that as soon as possible, right? Because the next batch for class 11th, for the JEE 2023 students is starting on coming Monday, right? Today also one batch got started. So please and please do get enrolled in the pro subscription. It's going to be highly beneficial for you. Okay, what all things you'll be getting over here? Let me tell you, first of all, we have got 3 plans over here. You can take any one of these plans if you want. Any one of these plans, right, you can take, and you can enroll yourself in the actual Vedantu platform. Well, people, in the first plan, which is the light plan, this is basically a plan for 2 years. It's a complete package of 2 years, right? This much of amount you have to pay, and no need to pay this much of amount in one go. No need to pay this much of amount in one go. You can pay this amount in EMI as well, in the form of EMI as well, right? And if you are new to Vedantu, you have no idea how the actual Vedantu classrooms look like, apart from the YouTube sessions. YouTube sessions are something different. These are the complementary classes, right? The actual classes are on actual Vedantu platform, right? Okay, which you can only join by taking any of these pro subscriptions. In the first pro subscription, if you are new to Vedantu, you can give it a try for a month. You just have to pay this much of amount, 2,700 for a month. See if you are getting benefited. Absolutely, you'll be getting benefited. Trust me on that. Just take the pro subscription for a month. See if you are getting benefited, then you can go for the 2-year classroom program. And I'm giving you the guarantee you will get benefited, right? In the light program. Similarly, we have got classic program as well, in which you get some extra thing, that is the doubt solving on mobile app. This is again a 2-year classroom program. This again a 2-year classroom program, and at the same time you can pay this much of amount in EMI as well. And if you are new to Vedantu, no issues, just go for a 1-month subscription. See if you are getting benefited, then go for the actual one. Then go for the 2-year classroom program. And similarly, there is one more at the end. Okay, in the last one, you get one special feature. You get a personalized mentor over here, right? Even this one you can take for a month. So people, if you want suggestions from me, do get enrolled in any one of these. Trust me, you are going to get benefited, right? And you'll be getting trained by the India's best master teachers of your physics, chemistry, as well as mathematics, right? And how to get enrolled, how to take these pro subscriptions, what you need to do is, there's a link in the description box of the video, okay? In the video, in the description box, you'll find a link. You need to click on that link. You need to use the coupon code of WBPRO. It is my personal coupon code. If you are using this coupon code, you'll be getting some 10-20% discounts as well. And I'll be training you personally over here on the actual Vedantu platform, apart from the YouTube classes which I take. Okay? And people, there is one more link in the description box. That's for the Telegram. Do click on the link, get added to the Telegram group, and stay updated about the classes. And the ones who have not liked the video yet, please and please do like the video. Share the video with your friends, and do not forget to subscribe to the channel as well, right? Do not forget to share the video with your friends so that they also get benefited out of these sessions, right? Well, people, it was nice meeting you. I'll see you guys tomorrow at the same time, 6 p.m. sharp. And tomorrow we are going to continue with the second lecture from this atomic structure. And the question which I gave you as the homework, please and please do give it a try, okay? And do let me know the answer of this question in the comment section, yeah? Thank you, guys. Thank you so much. Thank you so much. Well, people, it was nice meeting you. I'll see you guys tomorrow then. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.